everyone. My name is Kanchan Dikshit and I am working as an assistant professor in the Department of Computer Science and Engineering in ABES Engineering College, Ghaziabad. Today I am going to discuss about the Banker's algorithm. Banker's algorithm is an algorithm that is used for the deadlock avoidance. So we were not able to prevent the deadlock, so we are going for the deadlock avoidance now. So there are two types of state for a system. First one is the safe state and other one is the unsafe state. So for unsafe state, we can say we were not able to prevent the deadlock as well as we were not able to avoid the deadlock. So there is the unsafe state. But for safe state, we can say like there is a safe sequence of a system in which we will have to execute or allocate the resources to the processes so that there could not be any deadlock exist for the future. So we just have to make the scheduling of the processes in such a way, or we can say we have to schedule the resources allocation for the processes that needs to be executed in such a way so that the system could not enter into the deadlock state. So this is the algorithm. So now we are going to discuss in brief about it. So there are some details that will be required about the system while we are going for the Banker's algorithm. That is number of processes. What are the number of process? The total number of processes like P1, P2, P3, P4, P5. So there are N, that is 5. Now what is the maximum need of R? For each process, suppose there are A, B and C. These are the three resources required by each and every process. So for P1, suppose there is A, that is 2, 3 and 4. So two resources or two instances of A are required. For B, there are 3 need for P1. So this is the example for maximum need of resources. Now allocated. So A is allocated. Suppose A is completely allocated, that is 2. For B, there is only one resource that is allocated to P1. So for P1, we can say like for allocated amount of resources like for A, B and C. So we can say that 2, 1, 1. So now here we can see that A is allocated to, that is completely allocated, but it will require 2 more instances of B for the resource B for process P1. Now for C it is requiring remaining amount of 3. So here we can see like the total available amount of resources. So for for A, B and C, there will be the maximum allocation that could be provided to the processes. So suppose 10, 5 and 4. So maximum we can allocate 10 for A resource, maximum we can allocate 5 for B resource and maximum we can allocate 4 for C resource. So this is the total available amount of resources. This is the allocated amount of resources and maximum need of any resource by the process. There are the number of processes. These are the details required by the Banker's algorithm for finding the safe sequence of any system. This is the example. So there is some details that will be already given to you. The processes P1, P2, P3, P4 and P5. Now the allocated amount of resources A, B and C will be given to you, but this total you need to find out by yourself, right? Now the maximum need of the process to be executed, that will also be given to you. So this detail will be given. Now we have to find out the remaining need of each process. So we can see, we can find out here that maximum is 7, but allocated is 0 for A resource. So we can find out remaining need will be 7, right? Now for B we can find out allocated is 1 and maximum need is 5. So 4 is the remaining need. Now for C we can say 0 is allocated and maximum need is 2. So 2 will be required or remaining need. So in such a way, we have to find out the remaining need for each and every process, for each and every resource. Okay. So I'm going now 3 by minus 2, that will be 1, 2, and here we can see 6, 0. Now 2, 1, and 1. Right. So now we have to find out the available number of resources or available amount of resources. Now we are having total A amount of resource of A is 10, for B it is 5, and for C it is 7. Now we have allocated some amount of resources of A, B and C to each and every process. So we have to calculate the total allocated number of resources or amount of resources. So 7, 2 and 5 are the allocated amount of resource, and available is 10, 5 and 7. So for A, there is available amount of resource, that is 10, and for allocation I can see here that is 7. So I can see that from 10, if I'll minus 7, so available amount of resource will be 3. Okay. Likewise, I need to find out the same detail for B. So 5 minus 2, that will be 3, and 7 minus 5, that will be 2. Now I can allocate only these amount of resource to the remaining need of processes. Clear? So I'll find out that P1 I cannot allocate the available amount of resources because that are less rather than the remaining needs. So I'll go for P2. So P2 I can see here 1, 2, 2 could be allocated. So P1 will be, sorry, P2 will be executed. So P2 is executed. Now I can see 3, 2, 2 were the available amount of resource, and 2, 0, 0 will be free after the completion of execution of P2. So after the execution of P2, we'll have the resources that will be free, that were 200. So these will be added to the available amount of resources. Now I could see 5, 3 and 2. These will be the new available amount of the resources. Now I need to allocate these resources to the process. So this will be out of the system because this is already executed. P2 is already executed. So P2 will be out of the system. Now for P3, I will compare the remaining need to available ones. So these are again less than the remaining need. So P3 I cannot give. So for P3 I cannot allocate the resources. Now P4. P4 could be executed. Right. So P4 will be executed. Now P4, after the execution of P4, so these number of resources will be added to the available amount of the resource. So 2, 1 and 1. These will be added, right? So 7, 4 and 3. So this will be the new amount of resource for the allocation. The resources could be allocated to only P1, P3 and P5. So if I'll go for P1, then there will be, okay, I do have the sufficient amount of the resource for the allocation. P3, for P3 also I do have the sufficient amount of the resources, and for P5 I do have the sufficient amount of resources. But I need to take only one process. So I am taking P5. right? P5. So for P5, I can see that 002, right? So this will be added to the available amount of resources as we are considering that the execution of P5 is done. So it will be out of the system. So now the new available amount of the resources are 7, 4 and 5, right? So now I can allocate this amount of the resource to the processes. Now I can see P1 and P3 are waiting. So I will give the resources to P1. Now P1 will be executed and P1 is having 010. So 010 will be added to the available resources, right? So now I do have the new amount of resources, that is 7, 5 and 5, right? So 755 is the new amount of resource that could be allocated to P3. So now all of the processes have executed. Now I can find out the new available amount of the resource. So P3 is having 302. So 302. I can find out after adding 7 and 3 there is 10. That is okay. After adding 50 there is 5 and after adding 5 and 2 there is 7. So I can find out after completion of the execution of each and every process, we can find out the available number of resources will be equal. So this is all about the Banker's algorithm. We can find out the safe sequence or the safe state of a system with the help of Banker's algorithm. So thank you so much. For the reference, I have used operating system concept by Galvin, and thank you so much.